Welcome to Learning with the Boys and Girls Club, Periodic Table Part 4, Scavenger Hunt Part 2, and let's get started.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkyl react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, pneumatium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and oganesson, and then we're done.
So what do you need today? You need to bring your thinking cap, your pencil, paper, some periodic table knowledge, and it would really help if you participated in videos 1, 2, and 3. So especially video 3, where we had part 1 of the scavenger hunt. So come on in, and if you didn't participate in those, we're going to do a really quick review. But if you have seen all of this and you want to skip over it, you can skip straight to the scavenger hunt. So move on in and let's have some fun. Today we want to understand how the periodic table is useful and that elements' properties can be predicted from its location on the periodic table. So let's get started. Did you know that alkali metals are on the left, alkaline are in the second column, transition metals in the third, metalloids 13, reactive metals in the green, halogens in the 17th. Do you see a trend? Noble gases in the pink. Take a real good look in this area. All of the blue, light blue, are transition metals. The alkaline metals are in the red. Alkaline metals are in the gold. Reactive metals are in the green. Metalloids are in the light yellow. Noble gases are in the pink. Halogens are just those that are straight down on 17. Really take a good look at this. Pause it and take a good look at it. We're going to move on but I want you to actually pause it and take a real good look, because you're going to need to know this in something that we're going to work on later. So pause, take a real good look, and then move on with us. How is a periodic table useful? I'll bet you ask yourself that often. An element's properties can be predicted from its location on the periodic table. The periodic table is arranged in 7 rows called periods, from the left to the right, and the properties of the elements change in a pattern. Metals are on the left, metalloids are along the zigzag, and nonmetals are on the right. The periodic table is also arranged in 18 columns called groups or families. The elements in each group have similar properties. Metals. They are located on the left side of the periodic table and have physical properties that include luster, malleability, ductility, thermal conductivity, and electrical conductivity. They are solid at room temperature, except for mercury. You need to know that. Metals. Luster leaves shiny, reflective. Malleability is the ability to be hammered or rolled into sheets. Ductility and the ability to be drawn into thin wires. Thermal conductivity is the ability to transfer heat, and electrical conductivity is the ability to carry electrical current. You'll need to know all of that as we do our schedule. How are metals classified? Alkali metals. Lithium, sodium, potassium, rubidium, cesium, francium. You'll need to know all of those are in group 1. They are soft silver color metals. They are the most reactive metals on the periodic table because they have 1 valence electron because they are in group 1. How are metals classified? Alkaline earth metals. Beryllium, magnesium, calcium, strontium, barium, radium. Those are all alkaline earth metals in group 2, and because they are in group 2, they have 2 valence electrons. They are elements in this group are silver colored solids, just like alkaline metals, and I'm going so fast because this is just a review from both parts 1 and part 2, and you can stop any of this at any time and review yourself by pausing the video. How are metals classified? Transition metals are in group 3 through 12. If you look at the yellow and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all of that area. Okay, transition metals are less reactive because they are to the right and of 1 and 2. All right, nonmetals are located on the right side of the periodic table except for hydrogen and have physical properties that include dull, brittle, core conductors of current and heat, and lower densities than metals usually. Many are gases at room temperature. Diatomic molecules are nonmetals and naturally occur as diatomic molecules, which means they have 2 atoms bonded together. This is a single atom. This is a diatomic molecule. Diatomic molecules form 7 on the periodic table. Diatomic molecules. How can you remember the 7 diatomic molecules with a mnemonic device? Oh, I have nice closets for brooms. What? Yep. Oxygen, iodine, hydrogen, nitrogen, chlorine, fluorine, bromine. That's right. Oh, I have nice closets for brooms. OIHNCFB. Oh, I have nice closets for brooms. And if you look in the yellow, there are all of your elements. So pause the video and practice. But you probably practiced in part 1 and 2. So if you have this, you can move on with us. How are non-metals classified? Halogens, fluorine, chlorine, bromine, iodine, and astatine. That's right, group 17. They are very reactive. The elements in this group have 7 electrons. How are nonmetals classified? Noble gases, helium, neon, argon, krypton, xenon, and radon. Noble gases, group 18. They are usually non-reactive. The elements in this group have 8 electrons, except for helium, which has 2. Metalloids. Between the metals and the nonmetals on the periodic table are metalloids. They have some properties of metals and some properties of nonmetals. They are used to make semiconductors, which are substances that conduct electric current under some conditions, but not others. Semiconductors are used to make computer chips, transistors, and... Okay, now we've had our review. Let's have our scavenger hunt part 2. All right, let's have a scavenger hunt. Just like the last video, scavenger hunt number 1 and video number 3, we're going to do the same thing. We're going to read the question and then go to the periodic table in the next slide, pause the video, and then we're going to compare our answers when we come back to the video. Are you ready? Let's do it. Name the 4 elements that have similar properties to chlorine. Name the 4 elements that have similar properties to chlorine. They are fluorine, bromine, iodine, and astatine. If you got those 4 answers, you are correct. If not, go back and review. Let's move on. Which 5 elements have 5 valence electrons? If you said nitrogen, phosphorus, arsenic, antimony, and bismuth, the 5 elements that have 5 valence electrons, you are correct. In what state of matter is hydrogen at room temperature? If you said gas, then you are correct. Hydrogen is at room temperature as a gas. What is the chemical symbol for iron? If you said Fe, you are correct. Fe is the chemical symbol for iron. Which period is lead in? Period 6. You are correct. Lead is in period 6. Which element has the atomic number 92? Uranium has the atomic number 92. Which element has the symbol Sn? If you said tin, you are correct. In which groups can you find the transition metals? If you said that you can find transition metals in groups 3 through 12, then you are correct. What are the 6 nonmetals that are solid at room temperature in order of increasing atomic number? Carbon, phosphorus, sulfur, selenium, iodine, and astatine are the 6 nonmetals that are solid at room temperature in order of increasing atomic number. Great job. What is the only nonmetal in group 14? If you said carbon, you are correct. I really hope you enjoyed today's lesson and learned a lot, but don't stop the video yet. That song I know you love is coming up next.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells where electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinize at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells where electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olivinium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, pneumonium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done.
Look for other lessons such as how heat changes the temperature of objects, cool periodic table, real life stuff, what silly putty was really for, and why it all really matters. See you soon.